Hello, my name is Tim Roberts, and this is Group 2's video presentation of our project. To start things off, let's go over the scope of our project. We decided to enhance the security features of an app that we made last semester. Originally, there was no authorization or authentication features, and the passwords were stored in the database in plain text. To fix this glaring issue, we added some members-only features that are only available to users who register an account. So let's register an account so we can see what we added. Here I already have some info pre-filled in. So let's just hit register, and you'll notice that contact came up, and we now have access to get all the non-English words or translations for words. And if we log out, we get back directed to home, and we're prompted again to log in order to get back in there. So then we also added encryption to the passwords. At first, we just encrypted them with MD5, and that proved to be far too easy and simple to crack since it stays the same. And so then we decided to implement script, as you can see here. So I have some ones that were implemented with script. So for our attacks, we decided to try multiple different approaches, including password cracking, SQL injection, and cross-site scripting. Only the password cracking was successful. So now let us take a look at why that is. To do that, I'll hand it off to Ian, who will go more in depth on the subject.
Thanks, Tim. My name's Ian, and I'm going to be talking about the two attacks that we did onto the site using John the Ripper and Hashcat using Kali VM because it's built in already, so that's pretty easy over there. So I used the two hacking tools to crack MD5 encrypted passwords and plain text passwords, but in this video I'm just going to be going over the MD5 encrypted passwords, how the command looks, and just run it. So as you can see here, sudo john format equals raw md5 password.txt. So as you can see here to my right, the password.txt, these are the md5 encrypted passwords. This is going to be the command that you run to, of course, crack the passwords. It's pretty straightforward. Sudo is a command that allows me to run John the Ripper, John as in John the Ripper, format, which is going to be a MD5 style, using my password.txt file. So if I press enter, I already ran this command several times and it's pretty instant. Even the first time that I did it, it was pretty instant. So as you can see, it loaded up my two password hashes and no password hashes left, which means it was able to crack both of those encrypted passwords. So if you want to actually see the actual passwords, just use the same command, but use two hyphens, show right after John, press enter, boom. The two passwords, the first one is password, the second one is Bobby, and I can tell you those are the right passwords. Yeah. Next up, I'm going to be talking about Hashcat, which is the second tool that I use. So as you can see here, this is the command that I use to crack my passwords. Hashcat-a0-m0 password.txt rocku.txt force. So just going over through the command hashcat, of course I'm using the hashcat cracking tool. -a represents attack method. The 0 beside it represents straight. So I'm doing a straight attack. -m represents hash type. What hash am I using? MD5. That 0 beside the M represents MD5. I'm cracking an MD5 passwords. Password.txt, that's where my encrypted passwords are stored. And rocku.txt, that's a file that is considered my dictionary file with a bunch of words in which my password file will scan through the rocku.txt file to see if I can get a match and essentially crack my passwords, hence dictionary attack. So if I press enter, there's a little bit of information here. I already used this command beforehand, so I'm going to bring up a screenshot with a bunch more information, and this is when I used the command for the very first time. So as you can see here down below right here, the attack was successful. I got my first password, second password, Bobby, just as what we saw in the John the Ripper attack. And yeah, everything was successful, everything was good. This attack literally took like 2 or 3 seconds, so it's pretty fast, pretty instant. And it makes sense because the passwords weren't really that complicated, pretty basic stuff. And yeah, next up it's going to be my buddy Daniel talking about SQL injections.
Hi, my name is Daniel Derrich, a part of Group 2, and I'll be showing how to do a NoSQL injection on our API that connects to a MongoDB database. So the first thing to address is that the original source code compared the username to the database, only the username and not the password. So to make it more vulnerable, we changed it so it would have both the password and the username. So if you look at the API, a regular request returns the item. And if you get rid of that, invalid username or password, and then if you try our first attack, which is greater than nothing, which always returns true, and in this case it will return the first record in the list of users alphabetically. So the first one is Bill, and if you want to play around with this as an attacker, you can essentially get as many records as you want. For example, greater than A, or there's one record with a username of fake, so great, there we go, greater than fake, or G, and using that. And then another attack that you can do is to use the exists operator, which is a query operator attack vector, because it's always true that username and password will exist, and that also returns the first one. And this is a result of the find one function, as it allows for all the comparison operators such as greater than, not equal. And if you want to prevent this, all you have to do is do input validation before you use it to query to MongoDB. And by doing that, you would use the equals operator. So if you would just switch these two lines, where it compares it equals to a string, because we're trying to compare them as strings. So if we rerun this, and then we go to here, we can see that it failed to cast it as a string, as now it's being very strict with the equals operator. And thank you for watching my attack on our API.
Hi, my name is Sangkeun Kim. I'm part of Group 2. I also go by Steve, and I'm here to talk about XSS and XSRF, which is cross-site scripting, which we've all done a lab on, and cross-site request forgery, which we all read upon. So first part about cross-site scripting is that it is meant to be an attack where you pass JavaScript into user inputs and either save them or run them as is. Angular, which is what the app was built on, has built-in protocols to prevent attacks from XSS and XSRF. The key point being it does not trust user input, and it has a sandbox where it runs the code before sending to the end user, which means things like tags and Angular eval tokens do not work unless it was created from the program. So the program I use to test this is the XSSer, which is built into Kali. You can install it on Ubuntu or Windows 10. you would have to type in the location that you want to check the target of. You would aim and then you would fly. Because the site is simple and it's an Angular app, there's no actual attack that happens. We can see here's a test that I ran. This is something that we would have done in the labs, body on load tag. That would not have worked for any of the Angular versions. This eval token would have worked for the older Angular versions. It does not work for the current Angular versions.